Hello everyone, you are welcome to today's class. So in this class, we'll be looking at number bases, which is also known as numeral systems. So we'll be looking at these objectives. Number one is we want to look at the meaning. We look at common number bases that we have. Then also look at how to convert from one base to what to base 10. The other bases that we have to base 10. So these are the objectives we want to achieve in this video. So I don't want the video to be too much because we're going to deal with so many things here. So then proceed in the next video. So let's start with number bases. So when we talk about number bases or numeral system, these are ways of representing numbers using digits or symbols. So as you all know that throughout the whole world, we have uh, the counting system or numbering system that we use throughout the whole world, and that is base 10. We have the following digits that we use. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So how many are they? They are just what? 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is why all these digits are what we combine together to form any numbers that we want to form. For example, if I want to write 1356, I'll pick 1, I'll pick 3, I'll pick 5, I'll pick 6. All the digits that we have that form this number are from these 10 digits. So which is what? Base 10. So that is that on that meaning of number bases. So number bases, there are they are ways of writing numbers using digits or symbols or letters. Sometimes if we want to go beyond, by the time we get to the common number basis, you understand that. But if we want to go beyond 9, we have 10. So we're not going to use 10. We're not going to write 1 and 0 because 1 and 0, they are both part of this digit. So this is also base 10. But if we want to write another base, we will not write 10. There's something that we use to replace 10, 11, 12, 13, 14, 15, 16, and so on and so forth. Is that clear? So that is what we want to learn. That's the meaning of number bases or numeral systems, right? Numeral systems. Good. Then we move to common number. The common number bases that we have different kind of number bases. We have base 2, there's base 3, base 4, to up to base 10, 11, we have 12. But the common ones that we have, they are the common number bases that we have. So I've talked about the meaning. Then the next one is common number bases. Under the common number bases that we have, I will list them out. Number one, we have base 2. We have base 2. Base 2, which is also known as binary. So that you call it base 2 or you call it binary system. So number of counting. This one, because base 2, that means it has 2 digits. In it has 2 digits, 0 and 1. Then we have base 3, 4, 5, 6. But the more common one are the one I'm talking about here. We also have octal. Octal, which is also known as base 8. Base 8. Right? So this one makes up 8 digits from 0 to 7. So this one is what? 0 and 1, 0 and 1. Here we have 0 to what? 7. There's something else to bring out here. So another one is we have the one I just talked about, base 10. Base 10, which is also known as base 10. We have base 10, which is also known as binary, denary, or decimal. So this one makes use of digits from 0 to 9, 10 digits. Then we also have base 12. Base 12. Base 12, which is also known as duodecimal. Duodecimal. So that one has 12 digits. That is 0 to 12 digits to B. You understand what B stands for later on. So next one is base 16. Base 16. 16, which is also known as hexadecimal. Hexadecimal. Hexadecimal, which is from 0 to F. From 0 to F. So one thing I want you to notice here is this. So when you are dealing with a base, the highest digits in that base should be that base minus 1. So which means if you are dealing with base 5 now, the highest digit you can find in base 5 should be 5 minus 1. That is what? 4. Hope I'm making sense. So if you are now dealing with base 12, what will be the highest digit there? That is 11. 12 minus 1, 11. Right? So if you are dealing with base 2, the highest digit will be what? 1. That's why you have 1, 0 and 1. And base 10, if you look at base 10 here, right? The highest digit we have there is what? 9. You can have 10 as a single digit in base 10. Hope I'm making sense. So that is that on the common number basis that we have. But I need to dwell much on this aspect after base 10. So I want to dwell much on base 12 and base 16. You can see that we have letters here. We have B here, we have F here. Why that? Now, when you're writing number basis, I said that base 10 is from 0 to 9, and that is what we make use of throughout the whole world, anywhere you go in the world. So you can't see any numbers, any digit that go beyond what? 9. It's from 0 to 9. So we combine those digits together to form any number of our choice. Is that clear? So now we want to go beyond base 10. We want to move to base 12. And I said earlier on that the highest digit we can see in the base is that base minus 1. So if we're going to base 12, the highest you can see in base 12 is what? 11. But why are we going to write 11 down? It's not a single digit, it's 2 digits. If you put 11, 1 down, right? It will come to, so we fall under what? Base 10, because 11, 1 here falls under what? Base 10. I hope I'm making sense. So in that case, we will now use letters. So that's why when I was defining number basis, I said the way of writing or representing number using digits and symbols or letters. So here we're going to be making use of letters to represent 2 digits. So we start from 10. We have 0 to 9. Then 10. 10 will be A. 11 will be what? B. 12 will be C. 13 will be what? D. 14 will be what? E. While 15 will be what? F. So that is the reason why you can see that on the base 12 here, duodecimal. You can see duo means 2, decimal means 10. So 2 plus 10, that gives us 12. So we have from 0 to what? B. So B is what? 11. The highest you can see in base 12 is what? Is 11, which is what? B. While in base 16, which is hexadecimal, the highest you can find there is what? F. And F stands for what? 15. Hope I'm making sense. So if that is the case, we'll be able to solve this problem now. This common number basis that we have. These are the common ones. So others, we still have others, but these are the common ones that you usually see in exams, and others one are base 3, you have base 3, base 4, base 5, 6, 7, 8, and base 9. All of them, they are under number base. They are still fall under this one. But we don't have special. Oh, okay, 8. I've mentioned 8 here, right? We don't have special names for them, but these are the common ones we want to look at, and this one too as well. So now the next thing we're going to move to is converting from other bases to what? To base 10. To what? To base 10. So that's what we'll move to next. We want to look at how to convert from other bases to base 10. So we want to learn how we can convert. That's the same process. Right? You can find from base 2 to base 10, base 3 to base 10, 4 to base 10, 5 to base 10, and so on and so forth. So we have the same process. So I'm going to teach you one method in this video. So that is expansion method. So that's what we're going to look at. So solution to this, we have to convert the following numbers to base 10. So we look at the first one here. The first one is we have 3605. This one is in base 7. You can see the bases are written as a subscript below the number, just subscript. You can see not beside it exactly. As you can see, it's below it. So I can run, let me use figure here. That is 7. This one is in base 7. Now I want to solve this. We're going to expand these numbers, and for us to expand it, we're going to start from the last digit here. The last digit we have there is 5, followed by this. So we'll start from the last digit and we start from 0, 1, 2, 3. Right, that's the first step. You start from the last digit and move if the digits continues, you continue labeling it 0, 1, 2, 3. You label the top, just label it that way. So the next stage is we now start from the first digit here, which is 3 multiplied by the base. Multiplied by what? The base. And the base is what? 7. Raised to power, what we have on the 3 is 3. Raised to power 3. Is that taken? Plus, so this one is 1. You can put everything in bracket. The next digit, we know we have used the 3. The next digit is what? 6. 6 multiplied by the base. So if what you have as the base here is 3, we multiply by 3. This will be 3. This will also be 3. But the base is what? 7. Multiplied by 7. And this 6 is raised to power 2. You put it 2 on it. Plus the next digit is what? 0 times the base, which is what? 7. Raised to power, what do you have on 0? 1. Raised to power 1. Plus the next digit is what? 5. Multiplied by what? The base is what? 7. What is this one raised to power? Is on what? 0. So that's all. You notice one thing here, that the power, all these numbers are written on the base. Can you see? 7, 7, 7, 7. This is 3, 2, 1, 0. So don't write it on the number here. But it's written on this, on the number, on the digits here, but here it's written on what? On the base. Exactly. So the next thing is to expand this one to open the bracket. So that means 7 cubed now. You have 7 raised to power 3. So we're going to have 3 multiplied by 7 raised to power 3. Make use of a calculator. 7 raised to power 3. 7 times. So that gives 343 plus 6 multiplied by 7 raised to power 2 is 49 plus 0. Can still put in brackets. Do not make mistake. 0 multiplied by what? 7 raised to power 1 is 7 plus the next, this one, 5 times 7 raised to power 0. Any number raised to power of 0, please take note, any number raised to power of 0 is 1. Even if it is 1 million that is raised to power 0, the answer is what? 1. Even if it's a letter that is raised to power 0, the answer is 1. If you raise your name to power of 0, 1. If your name is Abdurrahman raised to power 0 is what? 1. raise anything to power of 0, the answer will be what? 1. So in that case, this will be multiplied by what? 1. So we then multiply it out on open. So that is 343 multiplied by 3. That gives 1029 plus 6 multiplied by 49. That is 294 plus 0 multiplied by 7. That is 0 plus 5. 5 times 1. So we add everything together. Plus 1029 plus 5. So everything gives us 1328. Base what? Don't forget we are converting to base what? Base 10. Put your 10 below it. That is the answer. So that means that 3605 base 7 is equal to 1328 in base what? In base 10. I hope this is clear. So move to the next one. The second one here is we have a 9 3 base 12. Good. So in this case, the same thing, the same method, the same way. So we have 0 1 2. So we'll go again. So let's start. So we start with the first symbol here, which is a multiplied by what? 12 raised by what? 2. Close it. Plus 9 multiplied by what? 12 raised by what? 1. Plus 3 multiplied by what? 12 raised by 0. Close it. So what does A stands for? A stands for, don't forget we've done that already before. So A stands for what? 10. So in that case, this will be what? 10 multiplied by 12 squared is what? 144. Plus 9, 12, that will be 9 times 12. Am I with you? Plus 3 times, what did I say the other time? I said anything raised by 0 is what? 1. Good. Good of you. So that means 12 raised by 0 is what? 1. I believe I'm making sense. So 10 multiplied by 144, that will be what? 1444. 1440, sorry. So this is multiplication by power of 10. Multiplication by power of 10. Just add 0 at the back of this one. If it is 100, you add 2 zeros at the back. If it is 1000, you add 3 zeros at the back. Right? Plus 9 times 12 is what? 108. 108 plus 3 times 1, that is 3. Add everything together. So we add everything together here. That is 1551 base what? Base 10. So that is that on this. You can see we are able to convert base 12 to what? Base 10. Right. So that is that on this. So move to number 3. Before we continue, let me tell you this. You see this topic, whether you are in JS1 or you're in SS1. When you're in JS1, year 7, you'll be taking through this number basis. And under this one, you might not go beyond base 10. But this is an opportunity for you to learn what you're going to learn in SS1. You see the same thing, right? So it won't go beyond it. You will not be seeing all this type of A and decimal here. You can see we have decimal, we have B, we have C here. You understand? So we will not be seeing all this one here. So that is what I want to tell you before we move to number 3. Okay. Question number 3. We are converting this to base 10 as well. So what we're going to do is still the same thing, but this is quite different from the last one we did, because this one has decimal, as you can see here. So what we're going to do, don't forget this is whole number here. This one is whole number, while this is what? Decimal part. So under this, we do the same thing. Starting from the units here, that will be 0, 1, and 2. Then after the decimal points, we will not start from, we not write 0 here, you now 1 here, 2 here, 3 here, 4 here. So this will then be what? -1, -2. So that's just the difference between the two. Difference between what we just finished now. So what we're going to do now, we do the same, we expand. That'll be 1 multiplied by 2. Then bring it to this side. 1 multiplied by the base, which is 2, raised by what? 2. Close it. Plus 0 multiplied by 2 raised by 1. Close it. Plus 1 multiplied by 2 raised by what? 0. Close it. Plus, where there's pointed, let me put 2 point there. Plus 1 multiplied by 2 raised by what? Minus 1. Plus 1 multiplied by 2 raised by what? Minus 2. Is that clear? Hope I'm making sense. So the next stage, we open this 1 multiplied by 4 plus 0 multiplied by 2 plus 1 multiplied by, anything raised by 0 is what? 1. 1 multiplied by 1 plus 1 multiplied by this 2 raised by minus 1. Please take note of this. 2 raised by minus 1 here. I want to change this. So what I'm going to do here is this. This minus 1 will change to what? 1 divided by the number, the base, which is what? 2. So if I have 2 raised by minus 2 here, this is what will happen. This minus will change to 1 over. Then 2 raised by what? 2. Right? So that means we're going to have the two different things. So this will be what? 1 all over 4. This will be 1 all over 2. So in that case, this will give me what? 1 multiplied by what? 1 all over 2. Plus, why this will give me what? 1 multiplied by what? 1 all over what? 4. Hope I'm making sense. Or I should write it 2 raised by 2. So you don't be confused. So the next stage is this. So multiply. This gives what? 4. This gives what? 0. This gives what? 1. Plus this is what? 1 multiplied by half gives us what? 1 over 2. This 1 multiplied by 1 over 4, that's 1 over 4. So which means this part gives us what? 5. 4 plus 0 plus 1, 5. Plus this, we find the LCM of this, which is 4. 2 in 4, 2. 2 times 1, 2. Plus 4 in 4, 1. 1 times 1, 1. So that gives 5 whole number. 2 plus 1, 3 all over what? 4. So that would be answer, base 10. So if you want to write it as decimal, just 3 over 4 is what? This will be 5.3 over 4 is what? 0.75. 5.7 what? 5 base what? Is 10. I hope this is clear, right? All right, for question number 4. So we're converting this to base 10 again, right? So the same thing, we do the same thing. We're going to do the same thing. Have this would be what? 0, 1, 2, 3. Why this would be what? Minus 1. Is that clear? So let's start with the first one. That will be 1 multiplied by 16 raised power 3. We close it. Plus b. What will b be? Don't forget what? That is 11. Because a stands for what? 10. B stands for what? 11. So this will be 11 multiplied by what? 16 raised by what? Raised by 2. We close it. Plus 2 multiplied by 16 raised by 1 plus c. C will be what? When b is 11, c will be what? 12. That will be 12 multiplied by 16 raised by what? 0 plus 3 multiplied by 16 raised by what? Minus 1, because it's decimal part, right? So we open this now. So that will be 1 multiplied by 16 cube. 16 cube. So that gives 4096 plus 11 times 16 squared. So that is 256, right? Plus 2 multiplied by 16 plus 12 multiply by what? 1. 16 raised by 0, that is 1, right? Plus 3 multiplied by 1 divided by the indices part, right? So the minus will change to 1 divided by 16, right? So that is that on this. Then we move to this. So 1 times this gives us 4,096 plus 11 times 256. That gives 2,816 plus 2 times 16, that is 32, plus 12 times 1, 12, plus this will give us 3 all over 16. So we add all these together. So we start from 4,096 plus 2,816 plus 32 plus 12. That gives us 6,956 plus 3 over 16 will give us 3 divided by 16 gives us 0.1875. So when you add these together, that gives 6,956.1875 base what? Base 10. So that is how to convert from one base, from other bases to base 10. I hope this is clear. So that's how to convert it. So this is where we're going to stop in this video. So we continue in the next video and looking at other aspects of it, how to convert from base 10 back to other bases, right? And how we can convert from other bases to base 10. Well, I hope you enjoyed this video. If you find it useful and helpful, so don't forget to subscribe to our channel and make sure you give us a thumbs up, and the same thing, you subscribe and turn on your notification bell so that anytime I post video or anytime I release any video, you'll be able to get notification of that video. So I wish you best of luck in your endeavor. Thank you. Meet in the next video. Bye for now.